Okay, so these notes are focusing on combination and composite functions, just operations of functions and composing new functions. So when you're adding, two ways that it can be written is f plus g of x, or it can be written as f of x plus g of x. All that means is you're going to be adding two functions together. So here, if f of x is 2x plus 1, and g of x is x squared plus 2x minus 1, you can make it 1 by adding them together. So f plus g of x equals 2x plus 1 plus x squared plus 2x minus 1, and then we just combine like terms. So we get f plus g of x equals x squared plus 4x, and that's it, because positive 1 and negative 1 cancel each other out. So f plus g of x equals x squared plus 4x. For subtraction, f minus g of x, which is the same thing as f of x minus g of x. If f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, order matters, so write f of x first. So f minus g of x equals 2x plus 1, and then minus, I'm going to put g of x in parentheses, so x squared plus 2x minus 1. And the reason why I put g of x in parentheses is because I'm going to need to distribute this negative. If you don't distribute the negative, this will be drastically wrong. So this ends up being 2x plus 1 minus x squared minus 2x plus 1. So I finish up with f minus g of x equals negative x squared. 2x, negative 2x cancel each other out, so plus 2. So f minus g of x equals negative x squared plus 2. When you multiply, it can be written as f times g of x or f of x times g of x. So if f of x is 2x minus 3 and g of x is x squared minus 1, you can write them together. So 2x minus 3 times x squared minus 1, and you can FOIL them together, or you could do the box method. I'm going to go ahead and just do the FOIL method since it's a 2 by 2. So 2x times x squared is 2x cubed. 2x times negative 1 is negative 2x. Negative 3 times x squared is negative 3x squared. And then negative 3 times negative 1 is a positive 3. And I'm going to rewrite it in standard form, so I get that f times g of x equals 2x cubed minus 3x squared minus x plus 3. So you're just multiplying the two terms together. For division, I don't know what all of this mess over here is. Ignore all this. So f of x over g of x, which can also be written as f over g of x. So if f of x is the square root of x and g of x is the square root of 4 minus x squared, to divide, you're just going to write 1 over the other. So f over g of x equals the square root of x over the square root of 4 minus x squared. And I'm completely okay with it being left like this. So you're just going to write 1 over the other. If you can simplify, then go for it. But if not, it's not a big deal. So I'm going to divide f of x over g of x. So f of x is x plus 2. G of x is x minus 2. So f over g of x equals x plus 2 over x minus 2. And there is nothing else to do there. So you're going to leave it exactly the way it looks. Okay, evaluating. If you do f plus g of x, that means you're just combining f of x plus g of x. But if you're going to do f plus g of 2, your first step is you're going to find f plus g of x. So you're going to add the two together. So f plus g of x equals x squared plus 2x. We did this on a page a few pages ago. Well, now to find f plus g of 2, anywhere you have an x, you're going to replace with 2. So 2 squared plus 2 times 2, which 2 squared is 4, plus 2 times 2 is 4, so we get 8. So we get that f plus g of 2 equals 8. So there's no different from the last problem or the last few problems, other than for now you're going to plug in a number for x. Okay, so again, I don't know what this right here is. This should be written as f over g of x. Okay, so for the sum, you can write it as f plus g of x or f of x plus g of x. Difference is f minus g of x or f of x minus g of x. The product is f times g of x or f of x times g of x. And then the quotient can be written as f over g of x or f of x over g of x. Composite functions mean that you're replacing the x value of one function with the other function. So f, this looks like an open O. That just means f of g of x is the same thing as f of g of x with the parentheses. Okay, so if you see the open circle, just imagine it's another set of parentheses. So the g of x is still the innermost function. So you're going to be composing a new function by plugging one into the other. You're going to be plugging the innermost function into the outer function. So I'm going to find f of g of x, given that f of x is x squared minus 9, and g of x is the square root of 9 minus x squared. So what I'm going to be doing, and you can rewrite over the open circle with parentheses, you're going to be taking g of x and plugging it into f of x. So g of x is the square root of 9 minus x squared, and I'm going to be plugging it in for x inside of f of x. So f of g of x equals, instead of writing an x, I've got the square root of 9 minus x squared, and then that's squared minus 9. And now you look to see, can you simplify? So the square root of 9 minus x squared, and then you square that, means you're canceling out the square root and the squared. So we have 9 minus x squared and then minus 9. Now combine like terms, so positive 9 and negative 9 cancel each other out. So I get that f of g of x equals negative x squared. So all you're doing with your composite functions is you're plugging one function into the other and then simplifying. And that is it for our operations of functions and composite functions.